Hello guys, in here we want to talk about synchronization and data dispersion. First, in here we have data of mathematics test score of 12th grade student. In here we have 30 data. So first we need to copy all of this into SPSS. We can input it in here. Then go to the variable view. We gonna let this decimal be 0 to make it more easier, and the data is like this score. This is the score of mathematics student. Next, we go to analyze, descriptive statistic, and frequencies. We input it into variable. We go to statistic in here. In here, we can check this whatever we need. In here, there is a mean, median, mode, sum, and minimum, maximum, standard deviation, SA mean, range, variance, skewness, kurtosis, and quartiles. And after we checklist all what we need, we continue. And then we can say OK. So in here we have the statistic. So for the mean is 79.57. So the mean of the data, the score of student is pretty good, 79.57. Next is median. So more than half of student the half of student is have 80 score, and there is the mod is 80 A. What is A? A is there is multiple mod exists, but in here it gonna show the smallest value. So the mod is 80. Then we go to the range in here. Range is the value of minimum and maximum score is 30 because the minimum score of mathematics student result is 65 and the maximum is 95. Next in here we got percentile. In here we can see that like we can see in here the median is 80 and the percentile for Q2 is 80, same because the median is same as Q2. Next from Q3 is 85, but so there is 20% of student is more than this. Next there is for the 25% is 71, so about 25% of the student is below 71. So it's for me. Thank you.
And the next is for the variance. Here we obtain the value of the variance is 72,047. Variance shows how much the data spread out from the mean. So in this case, a variance of 72,047 indicates that the participants' scores are fairly spread out, but still within a reasonable range, or it counts as moderate. And the next is for the standard error of mean, or SE mean. In here we have the SE mean is 1,550, which reflects how accurately the sample mean represents the population mean. So when the smaller the SE mean, the more precise the average. So in here we have SE mean is 1,550. It can be concluded that the sample mean of 79,57 is quite accurate and only slightly likely to differ from the true population mean. And then for the skewness, here we use this to see the normality of the data. And for the kurtosis, we use this to see the homogeneous of the data. Both of them will be explained further in the next section, which focus on it.
Hello there, so in here I'm going to show you how to represent the data in various forms such as table, diagram, or chart by using SPSS. So first of all, you need to prepare your data. Here I have my data in the Microsoft Excel. Next, you need to copy your data into the SPSS, so make sure you are in this data view. And then you can copy your data into SPSS. Here I'm gonna copy this column. and then pressing here, and then the other side. I'm gonna copy this and then press in here. So after you copy your data in SPSS, you can go into the variable view and you can change your data name in here. I'm gonna change here by score and this by gender. So after that, you can change the decimal into 0, the others too. So in here in my data, I have gender. Gender is not numerical, so we need to put value in them. We can go into value column, and then we are going to value 1 as a boy. I'm gonna add it, and value 2 as a girl. Gonna add that. Then OK. After that, we can go back into the data view. So first thing first, I'm going to show you how to represent this data in the form of column and row tables. You can go into the analyze and then choose the descriptive statistic and then into the 4 steps in here. So in here you can choose your data in the row or column randomly, but here I'm gonna choose score in the row section and then gender in the column section. After that, you can go to OK, and we have this as a result. So by this table, we can know that there are 4 people who is boy that has score 80 in the learning. Okay, that is the table form. Now we are going to represent this data as a pie chart. So we have this data, and then we can go into the graph, legacy dialog, and then we can choose pie chart. We are going to this summaries for group cases, define, and then because gender is not numerical, I'm gonna using score, choose score instead, and then we can choose OK. So here are the results. By this pie chart, we can know that the student that has 80 score is the largest amount of it, and the student that has the score this 50 and 100 is just a few part of it. So that is pie chart. Next, I'm going to show you how to represent the data by using the bar chart. So here I'm gonna this data again. We are going through the graph, legacy dialog in here, and then we're gonna choose the bar chart. We can choose the simple bar, define, and then choose the score in the category axis. Because gender is not numerical, so we're gonna leave there. We can choose OK. So here we have the bar chart of the score of student. Here we can show that the largest amount of student of their score is the student that has 80 score. Here there is 5 students in here. So that is using graph chart. And now we are going to represent this data by using line chart. It's kind of similar. You can choose the graph and then legacy dialog. After that, we can choose the line in here. We can choose simple line, define, and put the score in the category axis. Click OK, and then we have this line chart, similar as graph chart before. So that is a line chart by using SPSS. And the last, we are going to represent the data by using scatter plot. But I'm gonna use different data. Here I'm gonna use my second data. I'm gonna copy it first. This is data of the score of student in the control class and the experimental class. I'm gonna copy and put it side by the first data. And then I'm gonna copy the others too. Paste. Gonna put the experimental class data in here, side of the control class. After that, we're going to change the name of it. Going to change by control class. Control class. And here by experimental. Okay, we can change the decimal to by 0. After that, we can go back to the data view and we can choose. So we are going to represent this data by using scatter plot. So I'm going to use to the analyze and then to the correlate. I'm going to use to graph and then into legacy dialog and then into scatter order in here. We can choose the simple scatter, define, and I'm going to put contour class in the y-axis and then experimental class in the x-axis. It's basically up to you whether you put your data in the y-axis or x-axis. After that, you can go to the OK. And here is the scatter plot that we have from our data. This is the experimental class and this is the control class. We basically need this to find the relation between two data. In here, it shows that it doesn't really have a good relation, because if it has good relation, it will make a linear line in here.
Now we will try for checking the normality of a data. In here we have two data of the test that conducted in two classes, and I have input it from the Excel to the SPSS. Then don't forget to change the variable name. Here we change it in here, and we have class A and class B. Then change the decimals. Here I use the decimals are 0, and then change the measure. We use the scale 1. And for checking the normality, we go into the analyze and then choose descriptive statistics and frequencies. Here I have input both of the variables into this column, this box, and then we go to the statistics and check the skewness one. And then continue, and then go to charts and choose histograms, and don't forget to check this one, the show normal curve on histogram. Then continue, and then okay. Here we will have the table and both of the histograms. Here we see the table first. We have the skewness of class A is 0,084 and for the class B is 0,415. In here, since both values are close to 0, it indicates that the data distribution for both classes is approximately normal. And then if we see the histogram in here, we see that there there are no significant skewness detected for both classes, and meaning the data is fairly symmetrical or normal.
Now we are gonna move into describing the assumption of data homogeneity using kurtosis value. In this side, we have the match score data of class 8A and 8B, and we will see if the data fulfill the assumption of homogeneity or not. First step, we move the score data of two classes into the same column in page data view. And then move to page variable view and then change variable 1 to score. Change decimal to 0, change measure to scale, and then add new variable and name it class. Change decimal again into 0, and then change measure into nominal, and in the value double click, and then give value 1, and the label is 8A. Give value 2, and the label is 8B. Click add, and then click OK. Back to data view, and then we add column class, give 1 on kelas 8A, and give 2 in score kelas 8B. And then click analyze, and then click descriptive statistic, click frequency, and move score and class to variable, and then click statistic, and then choose kurtosis and click continue and click OK. Here the output of kurtosis. In statistic, we have the value of kurtosis is -1,128. The value is not too far from 0, so we can assume that the data is homogen. To strengthen our assumption, atau untuk menguatkan asumsi kita, we can look at the significant value. Significant value, to determine significant value, click analyze, and then click compare mean, click one-way ANOVA, and then move score to dependent list box, and then move class to vector box, click option, and then check or choose homogeneity of variant test, and then click continue, click OK, and we get the output here. We can see that the significant value is 0,0 949. It means this value greater than significant value that is 5%. Thus, we can conclude that the data that we have is homogeneous or the variance is same.
So guys, next we will talk about descriptive nominal and ordinal data. What is a nominal and ordinal data? Nominal and ordinal data is a categorizing data, and the difference is for nominal, it doesn't have order or rank, but for the ordinal, it have an order and rank. So for the example in here, we have data about merit status to life satisfaction, and in here, the nominal data is about the merit status, where not merit and merit is doesn't have a rank or an order. The next for the ordinal data is about life satisfaction, where there is have an order from not satisfied, neutral, then very satisfied. So how we can to describe this data? So first we will copy this data into SPSS in here. Then we go to variable view. We can name it like X and Y. It's up to you to name it X or Y. It doesn't have really matter that this is always X, this is always Y, So it's up to you to name it X or Y. Next, for the label, this is marriage status. This is a life satisfaction. Next, the decimal. To simplify it, we will choose 0. Then we put into the value. So in here, we already know the value. For the married status, 1 is for not married, 2 for married. So we can insert the label 1 in here. In here, not married. Yep. Edit. For the second one, married. So we already put the value into here. Next, from the ordinal data, for 1 is not satisfied. 2 is for neutral, and 3 is for very satisfied. Edit. Okay, so this is okay. We already described the data in here. We can go into analyze and then descriptive statistic, and we go to frequencies. In here, we insert all into the variable. Next, we go to statistic menu. In here, we can insert tendency. We can choose mean, median, modus. Next, in here there is another menu about quartiles and standard deviation range and so on. But in here we only need this, so okay, continue. For the charts in here we're gonna use pie chart with frequencies. Okay, we let this display frequency tables on, so we can go to the result. And here we got the result from SPSS. So this is the merit status, where there is but the frequency is 10 and not for the merit, and the merit one is 10. So we can describe that people that do this data, half of them is married and half other is not yet married. Next, we can read the life satisfaction, where not satisfied is 6, neutral is 7, and very satisfied is 7. And we can see in this pie chart that there is not satisfied, neutral, and very satisfied. But from this data, we know that people was more satisfied than the other, because even though neutral and very satisfied is on the same place, actually neutral it's like if we satisfied, we satisfied. So like that. So for the data, there is equal for the not married and the married one, and for the life satisfaction, the respondent of this data was satisfied in their life. So there is from me. Thank you.